Casper. I'm an electronic engineer and software developer, and I use KiCad. If you want to grab these slides, there's a lot of hyperlinks in here as well, and you can, anything I reference, you can look up the slides and you'll be able to get to the thing I'm talking about. So I'm going to talk about experiment of sorts. It's probably not hugely useful yet, but it's quite interesting, I think, and it's about defining PCBs as code and using code synthesis as an EDA tool. So it kind of all started with KiCad and the file formats in KiCad, the text formats, and like a lot of people, they use KiCad. I think I dove in and started editing things when the GUI wouldn't let me do what I wanted to do. And while I was doing that, I'd have my text editor on one side and KiCad on the other, and I thought, wouldn't it be nice if KiCad immediately refreshed the view when I edited it, and I could see what I was doing in a more kind of interactive fashion. And kind of in parallel to this, I was interested in Haskell, and I was learning Haskell, and I wrote a parser and a writer for the KiCad footprint format in Haskell, just because I had heard that S expressions are easy to pass, and that could be a good learning exercise. So I wrote this, and then I went kind of way overboard with the testing, and I checked it against every footprint I could find, and I used something called Quick Check, which is probably one of my favorite things about Haskell. It's a property testing tool where it will generate random test cases for you based on and then check them against your assertions. So if you say something is true about your program, it will generate random data, and as long as you tell it to do it, by default it'll try 100 times, but you can tell it to do thousands of randomly generated throw randomly generated data at your program to try and disprove your property, your assertion, which in the case of the parser and the writer, because they're symmetrical, is if I say if I write out my KiCad expression and pass that again, I should have the same expression. So I do that with this tool as well. But kind of back to S expressions, because as I wrote this parser, I learned more about them and how they actually they're not only easy to pass, but they're actually a representation of the parse tree. It's quite a simple representation, and I learned more about Lisp and the schemes and kind of other languages that make use of this. So I kind of I stumbled across Racket, which is touted as a programmable programming language. So what I found when I read up on Lisp is that there's quite a strong focus on macros and modifying the language and to your needs and defining new languages within the language because of the kind of the ease that S expressions allowed. That S expressions allowed this, for you to do this fairly easily. But so in Racket, it has quite nice GUI bindings as well. So, in the back of my mind, I was thinking about my editor and what kind of editor I wanted to create. So I was quite pleased that there's nice GTK bindings for Racket, and it has this IDE, which is where you can interactively play with Racket code. So when you start off with Racket, the first thing you say is, I'm going to use the Racket language, because that's not a pre-given thing if you're using Racket. So there's also something called a slideshow language. I didn't use this for my presentation, but you can interactively, in the REPL, it has graphical output and there's quite a lot of different languages. There's even an implementation of Python. So Racket kind of took this idea of using macros and modifying the language to the extreme that you don't even need S expressions in your language anymore. You can define other languages that don't use S expressions. So there's an implementation of Python in Racket. So I thought, wouldn't it be neat if not only we have an editor where we can modify the file format, but we can also kind of mix in a programming language into the format. So having a language, like a KiCad language in Racket. And this is kind of how far I got with it. I'd hoped to make more progress on this before I gave this presentation, but life kind of caught up with me, and I'm giving another presentation next, which is where I spend most of my time about open source hardware sharing platform. But just about this, so this is how far I got with it. So you can mix in this general purpose programming language into the KiCad format. So if you look at FP-Line, that's what the footprint format in KiCad looks like. And you can, here's a for loop that that outputs these FP-Line statements. So you can kind of recurse arbitrarily deep into this, and in the end it will flatten it out and give you your KiCad file back. So this is kind of what the code looks. That's kind of how that works at the moment. There's a syntax rule for the module, which is the high level kind of. This is my KiCad module, my footprint, which is defined as a drawing of items, and then we define the drawing. What it means to draw an item is to kind of execute all the functions that item is defined as, and flatten it completely so that you only have this kind of flat KiCad file. And there's a little bit of just checking what layer this footprint is on, and kind of translating that to something within the KiCad, within the record code here. So this, to clarify, this is kind of what the source of what my editor looks like at the moment. So this is kind of defining the starts of defining a KiCad language. So at the bottom, I define an FP text item with, again, that's a KiCad footprint expression, really. And I define it as a function that takes in the DC, which is a drawing context, and then executes functions on that drawing context. So this is really, I defined FP text as a drawing function. So I mean, kind of before you get too excited about all of this, it's really early days for this. I already mentioned I'd hope to make more progress on it, and this screenshot really shows what I've done in the best light possible. As in, I'm not using the right units. The line style isn't quite right yet. You can't really do anything useful with this yet. But just to jump ahead a bit, I had some more ideas surrounding this, and it would be nice actually to, if I manage to develop this further, to use the graphical part, so to do graphical manipulation, or traditional mouse-based manipulation, or direct manipulation, as well as the programming side, to be able to intermix these two. And I started thinking around this problem, and I came across a project which does quite a similar thing for SVGs. And you have this. They have a special DSL for SVGs, and then they have their graphical part here. And they've done quite a lot of. This is called Sketch, I believe it's by someone called Ravi Chung, and it's in development as well. And they've done made quite a lot of progress, and do some interesting things where the kind of the graphical manipulation side generates the code for you that isn't just is readable still and usable and modifiable on the code side again. But what I didn't find in Sketchit is some way for you to generate loops like this. And when I say loops, really this is a kind of a reversed map statement. If you're into functional programming, it returns the thing it defines. It doesn't just execute side effects. So I was thinking about this problem on how would I get my editor to generate this kind of code for me, and I came about, and I heard of the Rosette language, and I'd heard of like formal verification before, and I always thought, yeah, well, that's something that you do when you're working on safety critical systems, but I'd never heard the term programming synthesis kind of with this as well, which is what Rosette advertises. And Rosette is also a language in Racket. Now, what Rosette does is it connects Racket up to SMT solvers. That's satisfiability modular theory solvers which doesn't tell you much more if you don't know anything about it. But what it essentially means is kind of similar to what I was doing with the Haskell testing, but instead of just picking up random, generating random data, it actually tries to exhaustively go test every possibility. It's like an exhaustive testing tool. Now this doesn't sound. It really doesn't sound possible. And then if you ask me how does this work, it's really very complicated because it's essentially an NP-hard problem, and there's a lot of interesting algorithms that go into it, and that's kind of out of the scope of this talk, by which I mean I don't know really. But there's a lot of SMT solvers, and it's an active area of research, and the one that Rosette uses is Z3, which is actually written by Microsoft. Microsoft Research, and is MIT licensed. And so, again, Rosette kind of hooks up the confused programmer, which is you right there with the question mark, and gives you, lets you use Rosette to generate, to do programming synthesis. And this is kind of the talk that got me into all of this, and it's a very good talk, and I would recommend it for anyone interested in the subject. And the links are in the slide. But there's a bit of a question. If you've understood now that it's an exhaustive checking tool. The SMT solver is an exhaustive checking tool, but how can this be used for synthesis? And really, the way so far, if I understand it correctly, if anyone knows more about this, feel free to interrupt me if I'm, speaking nonsense. But you pretty much give it a template of your desired construct. So you could give it an empty for loop, and you leave kind of the holes in there, the question marks, and then you I've left the it's the next slide, and then you can give it an assertion about your code. So you would say, I want to synthesize something that's the equivalent of, if we go back. So this is trying to generate a pad at a particular location, kind of simplified KiCad expression there. And you could say, I want this to be the equivalent of a pad at 0.1 and a pad at 0.2. And then you could, with Rosette and this assertion, get a Rosette and back through the SMT solver to give you the solution to that. What kind of for loop construct is required to get this output here? I mean, you might think that, well, that's a lot of complicated stuff that you'd have to learn to maybe make something that's not necessarily useful. I mean, I find it interesting. I'm not sure footprints are necessarily the best application for this. One of the most exciting things about all of this research is this is a feature in Microsoft Excel, which is called flash fill, and they use programming synthesis, and it's from the same. I believe the person that came up with this was studying with the same people that I keep linking in, and this kind of from examples. If we go back to when it loops back to this out there, you give an example and you say flash fill that. And it tries to figure out what kind of transformation you wanted on that data. So it writes a little tiny program for you to do that transformation. And it might say, I don't know enough about what you've told me there to synthesize all that. And if you give it another example, it will be able to figure out what you wanted, what kind of program you wanted to generate. So that's my talk for now. It's a little bit short, but so there's quite a lot of time for comments, suggestions, questions. Yes?
So in Rosette, it's going to be using program synthesis using constraint solving.
Yeah.
And constraint solving is used in EDA in many areas. For instance, simple cases, matching impedance along the line, with some transmission line and so on, can be seen as a constraint solving problem. And layout itself, just auto layout, is a huge constraint solving problem.
All right.
However, it's usually done on the kind of low level. If you can, we can express, for instance, like you have an operational amplifier, it's supposed to have an amplification of 10, whatever. If you can express that logic somehow, maybe using racket or whatever, now you can say like, okay, I have a resistor value as well. Or like tell okay, or I have a library of resistor values available locally. It's generate me a design which works given this schematic.
Right, yeah.
So this is, I think, a very interesting aspect of.
Yeah, I think there might be there might be more like I said, there might be more interesting areas than for editing footprints. I quite like using the footprint format because it's quite limited, and I can get somewhere quickly. But yeah, I'm sure there's more interesting applications. Any other? Yep.
So is this what exactly parses your code that you added to the footprint? Because as far as I understand, the thing that you write is not parsable by KiCad, so you have to have some intermediate program, right?
Well, the way I envision it to work is that you can write arbitrary code in here, and actually, if I ran this, you could go up here and say on the module and say kind of execute all of that, and then you get your normal KiCad PCB expression, and then you can save that. And I'm not quite sure how those two formats will work out.
Matchbox, by the way, which is something we developed.
Sorry?
Kind of does the same thing with the Python instead.
What's that? Sorry?
Matchbox, which is
Mac ports.
MADP ports.
Mad parts. Yes, I have seen that. Yeah. Yeah.
So I was wondering if this could be interesting if KiCad could read this format because it's already pretty similar to what is there.
Yeah, I mean KiCad, the KiCad reads. This is the KiCad footprint format. I mean, except for the for loop, really. So if here's a footprint. This is what the KiCad format looks like. So you just need to flatten it to get it into KiCad. Yeah.
For footprints, antenna design is one area where working with some higher level tools than manually doing out some of these is
Right. That's very interesting. Yeah.
And the way people do it today, usually you just find a book or something with a recipe of how you do it. So you just avoid the general problem, you just go to specific problems. But there are some cases where that means that most antennas are very basic. Planar antennas just radiating one direction because there's no solved problems. You just change your spacing. But in general, if you can, this requires a lot of kind of domain understanding. But if you can express that, you can generate something. I think this becomes very interesting when we go past PCB layout into the copper substrate, which is what we're currently doing. Then we were looking at, say, doing layout in 3D. So saying we're doing additive, our paths are additive, made with a 3D printer. We don't have design tools that can do this in any good way. But if you can express the problem, you can kind of do it for you.
And even before that, you have flex anyway. Today, like your PCB is maybe not going to remain flat on a surface or rigid. So.
Yes, flex and multi. Like you might want to use your walls as your PCB and so on.
Any other?
Okay, let's thank Jasper again. Water bottles there if you want.
Yeah, I've got one. Yeah, a little bit short.
That's good. It allows people to move in and out.
Oh. I really enjoyed your talk. Really good.
Thanks.
I especially like the high level overview. It was good. It was really good for me.
Okay. You're there. I hope that there will be more KiCad developers.
Yeah. I would keep meaning to. I keep going up. I keep getting the source, compiling it, looking at it. So it was good to get that high level view how the thing is going.
We'll see.
Yeah. Would that the example tool, would that work for both canvases then? Is that fine?
Currently, no. The
So this is for GAL.
Yeah, it's only for the GAL.
Oh, gotcha.
Because in the end, we would like to have GAL, both in PCB and
Yeah,
and after that, we have a very consistent way of writing tools.
But that's not in 5, is it? Still, 5 will still have legacy.
Well, there are both.
Yeah, I know they're both. But was it even on 6? Get rid of legacy cameras?
Yeah, probably.
Probably on 6, okay.
Yeah, there are just a few things probably that we need to port from the legacy to the new canvas, and after that we can try to drop it.
Yeah. I'm trying to think what I miss. Sometimes I switch back, I can't remember why. Sometimes I think quick deleting, like a shortcut. I think my shortcuts are not transferred somewhere or something.
Removing whole track or something.
Oh yeah, removing segments. Can I do that?
Yeah, I think you can do it with push and shove router when you have it enabled and then you hover over a track pre-delete, which removes the whole connection. But it's a bit different than the legacy, so perhaps not many people really recognize that there is such option for that.
I'm out of water.
So now you're going to this?
Hey?
Now it's your turn.
My turn again? Yeah, this is why I didn't.
Wouldn't it be useful if you had, for instance, databases with commonly known ICs and SMDs, where all the connections are known? If you have that database that you can extrapolate with the language those footprints, and let KiCad automatically generate from a database given from a manufacturer.
Yeah, I'm not sure this would help that much. If you've got the drawing, if you've got the database and you've got the footprint, you wouldn't really need this. The only thing is if you want to do parametric thing. The other area is interesting. If you look at like 3D CAD, they do constraint-based CAD. You say, I want this to be here, I want this to be here, and then I think the code synthesis and the constraint solving could be quite useful again.
Like in FreeCAD, for instance, if you have a flange and you have put in 10 holes, you augment the diameter from the flange. It either will disperse the holes, if you have 10 holes, over the wider diameter, or it could be that if you fix the diameter that he puts in 2 more holes.
Yeah, so that's parametric. Yeah.
That's about the gist of it.
That's cool. I'm going to prepare my other presentation. I'm so glad the internet's good with all this. Close. Oh my. Oh yeah? Have you? I think I can't. The keyboard's not working. The keyboard doesn't seem to be working.
Oh, is it blocked?
I don't know.
Strange.
Oh, that
It
works.
seems to be working.
I'm just trying to.
It's just that, okay, maybe in full screen mode it doesn't work, I don't know.
This one definitely.
Strange.
What?
I don't know. Close and reopen it. I don't know. I've never actually played with two screens at the same time.
Okay. There we go.
So I go for 20 minutes of speech and then 5 minutes for questions.
Yeah.
the nodes.